Physics review video, Unit 3, Accelerated Motion, Skill Freefall Problems. Today we will be looking at what happens when an object is only affected by the force of gravity. And we'll do a few example problems, and hopefully you can apply those skills to the problems that you're working on now in class. Okay, equations. These are the same equations that we've had for accelerated motion on a ramp. So we have delta x equals 1/2 at squared plus VOT. We have delta x equals 1/2 v plus v naught times t. We have v squared equals v naught squared plus 2a delta x. And we have v equals at plus v naught. Four base equations. Those are our accelerated motion equations. The only difference now is something is being either thrown up or thrown down or thrown across or rolling or falling. So we have to use gravity. Our A is gravity, which is going to equal negative, because it's down, 9.8 meters per second squared. Sometimes I'll even write it as AG, acceleration due to gravity. You'll see that in some books. Some books will even put just a G. You're supposed to assume that that means gravity, but gravity will always be 9.8 meters per second squared down. So we are going to use a negative sign. We're going to make the assumption down is negative, up is positive. If you would like to make a different assumption that up is negative and down is positive, just flip all the signs to the exact opposite of what I'm doing. You'll get the same answer from each time. But I like going up positive, down negative for this. A couple things to remember other than up positive, down negative is if you throw something up, it's going to come down because of gravity. If you throw something up, when it gets to the very top, the apex, your velocity at that point is 0. Why? Because you're going from positive to negative. In the middle there, that has to be 0. Your acceleration will still be negative 9.8 meters per second squared, but your velocity at the top will be 0. Let's try some problems. Like every word problem, really just read, figure out what you know, what you don't know, pick an equation. Here's an example. A ball is dropped from a 20-meter tall building. How long does it take to reach the ground? Okay, so how long? I know there's a time in there. I know the building is 20 meters tall. That's a height. So my starting position is up in the air 20 meters. The ground, my final position will be 0. Something else we just talked about. My A is gravity, negative 9.8 meters per second squared. And there's one other thing that's going to come up a whole bunch of times this unit. Something is dropped. Something is dropped means the initial velocity is 0. Just think about it. You're dropping something, its starting velocity is nothing. So I have V, x, x naught, a, and t. Probably my best equation to go with, if I look back, would be the first one. So delta x equals 1/2 at squared plus VOT. Now notice a couple of things. I don't have a delta x. So we're just going to substitute x minus x naught here equals 1/2 at squared plus VOT. Let's plug in. 0 meters minus 20 meters equals 1/2 negative 9.8 meters per second squared t squared plus 0 meters per second times t. Let's make some simplification. 0 times anything is 0. That disappears. Simplify over here. Negative 20 meters equals negative 4.9 meters per second squared t squared. You know with your algebra, we're going to divide both sides by 4.9 meters per second squared equals t squared. So our t squared, when we punch that into the equation, equals, negatives go away, meters go away, seconds flip, 4.08 seconds squared equals t squared. So root that. Second square root, probably second answer in your calculator. You get a time of 2.02 seconds. Let's take a look at the second part. What's the velocity of the ball as it hits the ground? Well, now I know I want v. So I have v. I knew I had VO still. I had my delta x ended up being negative 20 meters, x minus x naught. And my acceleration is still gravity. So v, VO, a, delta x, I could use this. V squared equals v naught squared plus 2a delta x. V squared equals 0 meters per second squared plus 2 times negative 9.8 meters per second squared times negative 20 meters. My 0 squared goes away once again, so 2 times 9.8 times 20. My negatives go away. I get v squared equals 392. Look at the units. Meters squared over seconds squared. Let's take a root. And I get v equals two answers. I get negative 19.8 meters per second or 19.8 meters per second, because every time you take a square root, you get a positive and a negative. You have to pick which one makes sense. The ball's coming down. That's my answer that makes sense. Technically, you did have a negative 2.02 seconds as an option on the first part of the problem, but we know we're not dealing with negative time. Let's take a look at another set. Now we're going to throw the ball upwards. Ball's thrown upwards from the ground with a velocity of 20 meters per second. Know my initial velocity right there. What is the maximum height the ball reaches? Well, I know gravity, negative 9.8 meters per second squared. I want maximum height, so I want x. And we know something. When it goes to the top, I know my final velocity at the top is 0 meters per second. Equation I would use, v squared equals v naught squared plus 2a delta x, and that delta x will become x minus x naught. Let's plug in 0 meters per second squared equals 20 meters per second squared plus 2 times negative 9.8 meters per second squared times, I don't know my final height, minus the ground I started at, 0 meters. So if we simplify all of this, I get 0 equals 400 meters squared over seconds squared minus 2 times 9.8, negative 9.8, minus 19.6 meters per second squared times x. Let's finish some algebra up. Negative 400 meters squared over seconds squared equals negative 19.6 meters over seconds squared. Let me clear a little room so you can read. Times x. Let's divide both sides. Looks like my maximum height will be 20.4 meters. So we got another one. How long will it be in the air? Now we want time. Time, initial velocity, positive 20 meters per second. At the top, how long is the ball in the air? The ball goes up and comes down. So my change in position is 0. And we still know gravity. So there's only one way to go this way. Delta x equals 1/2 at squared plus VOT. 0 equals 1/2 negative 9.8 meters per second squared time squared plus 20 meters per second times time. This is either a quadratic or a factoring problem because you are getting 0 equals negative 4.9 meters per second squared t squared plus 20 meters per second t. Definitely looks like a quadratic. You can go to Good Quad in your calculator, get that from one of your teachers, or you can factor this out. That will also work. Either way, you get two answers. You get time is equal to 0 seconds, which should make sense because the ball is on the ground at 0 seconds. And you get time equals to 4.08 seconds. Which one makes sense? 4.08 seconds. Last one. We want the velocity when it strikes the ground. We want v. We know v naught, 20 meters per second. When it hits the ground, that was a change of position of 0 meters. We still know gravity, negative 9.8 meters per second squared. This equation, v squared equals v naught squared plus 2a delta x. Let's plug in some numbers. I have a 0 meters here, negative 9.8 meters per second squared, and a 2. That we know that's going to go away. 20 meters per second squared, and v squared. 0 times anything, that all goes away. So I have v squared equals 20 meters per second squared. Root both sides. V equals positive 20 meters per second or negative 20 meters per second. You have to decide. It's coming down to hit the ground. That would be negative 20 meters per second. Your direction is the negative side.